transformation of a chemical substance into another chemical substance is known as a chemical reaction. Let's see the different types of chemical reactions, which includes combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction reactions, and endothermic and exothermic reactions, of which decomposition reactions are further classified into three: thermal, electrolytic and photolytic, and double displacement reactions are classified into two: precipitation and neutralization reactions. So let's see each one in detail. Combination reaction. As the name suggests, in this reaction, two or more reactants combine to form a single product. For example, magnesium burning in air to form magnesium oxide. Here there are two reactants but just a single product. The second type of reaction is decomposition reaction. Now, decomposition reaction can also be considered as the opposite of combination reaction, because here a single reactant decomposes to form two or more products. Decomposition reactions are further classified into thermal, electrolytic and photolytic decomposition reactions, of which thermal decomposition means the reaction takes place in the presence of heat. For example, calcium carbonate, when heated, it gets converted to calcium oxide and carbon dioxide. So, it is a decomposition reaction which is taking place in the presence of heat. Electrolytic decomposition means that the reaction takes place in the presence of electricity. That is, if you pass electricity through water, it gets divided into hydrogen and oxygen. So, that is an electrolytic decomposition reaction. The third type is photolytic decomposition reaction, also called as photolysis, which takes place in the presence of sunlight. If silver chloride is kept in presence of sunlight, it gets converted to silver and chlorine. So, such a reaction is called as photodecomposition reaction or photolysis. Now, coming to the third type of reaction, which is displacement reaction, also called as single displacement reaction. In this reaction, a more reactive metal displaces a less reactive metal from its salt solution. For example, if you react zinc with copper sulfate, zinc is more reactive than copper. So, zinc displaces copper from its solution to give zinc sulfate and copper. So, such a reaction is called as single displacement reaction. Now, in order to understand displacement reactions really well, you need to know the reactivity series of metals. That is, potassium is found to be the most reactive metal in the reactivity series. As you come down, the reactivity of metals decreases and gold is the least reactive. Now, coming to the fourth type of chemical reaction, which is double displacement reaction. This is also a displacement reaction. It is just that there is an exchange of ions taking place there, which means both the metals displace each other. Double displacement reactions are further classified into precipitation and neutralization reactions. Precipitation reaction is a reaction wherein a precipitate is formed. For example, when silver nitrate reacts with sodium chloride, silver chloride and sodium nitrate is formed, of which silver chloride is a white precipitate. Plus, you can see that there is an exchange of ions taking place there, and that is why we call this reaction as a double displacement reaction. The second type of double displacement reaction is the neutralization reaction. When an acid and a base reacts with each other, you get salt and water. In that reaction, both acids and bases, they are neutralizing each other, and that is why we call that reaction as a neutralization reaction. And also there is exchange of ions taking place there, so it is also called as a double displacement reaction. Now, coming to the fifth type of chemical reactions, which includes oxidation and reduction reactions. Oxidation means addition of oxygen or a non-metallic element, or removal of hydrogen or a metallic element from a compound. And the elements of compounds in which oxygen is added or hydrogen is removed is said to be oxidized. So, what is reduction? It is just the opposite. Addition of hydrogen or removal of oxygen from a compound is called as reduction, and the compound or element which undergoes reduction is said to be reduced. Now, let us see what are oxidizing agents and reducing agents. They are definitely different from reduced substances and oxidized substances. The substance which gives oxygen or removes hydrogen for oxidation are called as oxidizing agents, whereas the substances which gives hydrogen or removes oxygen for reduction are called as reducing agents. Redox reactions. That name clearly indicates that there is both reduction as well as oxidation taking place simultaneously. Yes, you take an example of carbon dioxide reacting with hydrogen to give carbon monoxide and water. Here you can see that carbon dioxide is getting converted to carbon monoxide, which means there is removal of oxygen. So it is reduction. Whereas hydrogen gets converted to water, there is addition of oxygen, so it's oxidation. So in the same reaction, there is oxidation as well as reduction taking place, and that's why you call that reaction as a redox reaction. Now coming to the last type of chemical reactions, which includes exothermic and endothermic reactions. When a reaction releases energy, you call that reaction as exothermic reaction. Whereas when reactions absorb energy, you call that reaction as endothermic reactions. The best example is the food that we eat contains glucose, which is C6H12O6. It reacts with the oxygen that we take in to form carbon dioxide and water plus energy that we use to do various kinds of work. So there is release of energy there, and that's why we call that reaction as an exothermic reaction. But there are certain reactions which will take place only if you absorb energy. For example, calcium carbonate can be converted to calcium oxide and carbon dioxide only if you supply energy to it. That is, you heat it so as to get converted to calcium oxide and carbon dioxide. Now let's see some of the effects of oxidation reactions in our everyday life. Have you noticed that your silver metals, your silver bangles and ornaments become black after some time when exposed to air for a long time? Also, the copper vessels in your house slowly loses its shiny surface and becomes a green coating. And the iron articles forms a flaky brown substance called as rust. Yes, metals when exposed to moist air for a long period of time, they become corroded, and this process is called as corrosion. So what is corrosion exactly? It is the slow conversion of metals into their undesirable compounds due to the reaction with oxygen, acids, water, gases, etc. present in the atmosphere. For example, rusting of iron, which is a very common example. Iron reacts with oxygen and water present in air to form iron oxide .XH2O, which is that flaky brown substance called as rust. Corrosion is definitely a disadvantage because it weakens the iron and metal objects and structures such as railings, car bodies, bridges, ships, etc. and cut shorts their shelf life. So what can we do to prevent rusting or corrosion? You can either paint it, you can do greasing and oiling, or you can use techniques such as galvanization. Rancidity is another effect of oxidation. The taste and odor of food materials containing fat and oil changes when exposed to air for a long time, and this process is called as rancidity. It is caused due to the oxidation of fat and oil present in the food materials. So what do we usually do to prevent rancidity? We will either refrigerate these foodstuffs so as to increase their shelf life, or you can use antioxidants. You can use vacuum packing as you see in these chip packets. Also, you can replace air with nitrogen to prevent rancidity. Now to summarize, the different types of chemical reactions includes combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction reactions, and exothermic and endothermic reactions, of which decomposition reactions are further classified into thermal, electrolytic and photolytic decomposition reactions, whereas double displacement reactions are converted into precipitation and neutralization reactions.